So, part B. Consider the following sequences. Sequence. What's a sequence? Well, you know what? A sequence is simply a pattern, but it's a pattern expressed using, notice what's between the numbers there. Using commas. In a few days, we'll do a pattern expressed with addition signs. That's called a series. We're going to do that later. Okay? Remember that? Sequence and series. Okay? This is just a sequence. So it's a pattern. All right. 2, 6, 10, 14. Da-da-da. Okay, when you have a sequence, you name each term A sub, and then whichever term it is. This is the first term, so it's A sub 1. That's A sub 2, A sub 3, A sub 4. Okay? You can use any name that you want, but typically in math it's labeled as an A. Eventually you're going to get to any term is A sub n. That would be any term out there. Okay? All right, now let's look for a pattern here. Look how I got from 2 to 6. I'm going to multiply by 3, but you'll find out very quickly that's not going to be the pattern, is it? Plus 4, plus 4, plus 4 again. Okay, so we're adding by 4. All right, first question. Do you think that this sequence will be convergent or divergent? Now we're using the adjective instead of the verb as we did before. Right?
Divergent.
Okay. It would be diverging because won't those numbers just get bigger and bigger and bigger and bigger? Sure. So that is definitely divergent. Excuse me writing. All right. Okay, divergent. All right, so that's just going to go crazy. As a matter of fact, you know what would happen if you graph this? 1, 2, 2, 6, 3, 10, 4 gives me a 14. It would make a line because it's going up by 4, up by 4, up by 4. It's linear. It's the same amount of increase, right? So that's a line. And of course, a line, there's no way that a line can converge. You can't bend, right? So that's divergent. All right, now, the fifth term. The fifth term would be, what's the next one? 18. Or if you really want to impress Mr. Wade, you could say positive 18, but you could also say A sub 5 equals 18. That would be very nice. You don't have to do that, but okay? That would be very nice. Okay, now, next one. 3, 6, 12, 24, 48. You know what? We are doing what? Multiply by 2, multiply by 2, multiply by 2. Okay, convergent or divergent? That is going to be, oh yeah, those numbers can go up really fast, aren't they? That is most definitely divergent. Matter of fact, this one's not linear, it's definitely not a line. This one is a different type of curve, actually. Double, double, double. It's exponential. Exactly, very good. That is an exponential curve that skyrockets. Very nice. Stephanie's girl. All right, this is going to skyrocket here. This is definitely an exponential if you graph. And the next term would be what? That'd be 48. Okay. And if you want to note that this is linear and this is exponential, that'd be nice too. So you can kind of picture it in your head. Okay. All right, third one. 16, negative 8, positive 4, negative 2. It's going all over the place. Matter of fact, it is oscillating, right? Okay. How do you get from 16 to negative 8?
Divide by negative 2.
You can multiply by negative 1/2, or you can divide by negative 2. Either one's fine. Very nice. Well done. And you can write that either way. Actually, I kind of like the multiply by negative 1/2. Okay, so you are basically cutting it in half, but then changing the sign each time. Okay, all right. Now let's see. Eventually, what's going to happen here? I've got 16, negative 8, 4, negative 2. You know what's happening?
It's approaching 0.
Yeah, it's going like this. All right?
Somebody dying.
Yeah, exactly.
It's like
Getting closer and closer and closer. Okay? It's surrounding that zero right there. That is convergent. All right, so let's put a convergent for that one. By the way, If you are dividing, that's usually also an exponential. It's just coming in for a landing, okay? Although this one's kind of going haywire and coming in for a landing at the same time. So, very special case, okay? But it is coming in for a landing of sorts. So what would be the next term after this one? Positive 1. So that would be a sub 5 equals positive 1. Now, do you realize that it's going to go to negative 1/2, positive 1/4, negative 1/8, positive 1/16, and it gets closer and closer and closer. Never gets to 0, but it is converging towards 0, right? And very close. Okay. All right, good one. All right, so now next one, 10, 7, 4, 1. Ooh, that's getting really close to 0. I think it's coming in for a landing, kids. Actually, it's just going to go right through the ground and then just keep digging its way through the china. Right? -3, -3, -3. If you keep subtracting 3, you will eventually arrive at what? Negative
Infinity.
infinity. You never quite get there, but you get towards that direction, right? So negative infinity. So that one goes down forever. So this one is going to be known as divergent. And by the way, if you were subtracting, isn't that kind of like adding?
Yeah.
It's just a what? It's a line with a
Decreasing.
negative slope, yeah, so it's just going down. So also linear. All right, so that's divergent. So the fifth term would be what? -2. Then -5, then -8, and it just keeps going down and down and down. Okay, divergent. Okay, all right, and now the last one. 3, -5, 7, -9. Oh, you know what? It's another one of those, all right. Take 2, kids. It's actually part 2. All right. Now, a little clapping here. Okay. Now, all right. So 3, -5, 7, anyway. All right. This is another one of those. Trying to get to the back page. Okay. This is another one of those whats. This is oscillating back and forth. How do I get from 3 to -5? Subtract 8. How about -5 to 7? Plus 12. How about 7 to -9? Minus, this is a more advanced pattern this time. Interesting. Do you think it'll converge or diverge? 3, -5, positive 7, -9, you know what? It's getting further and further. It's going to explode, all right? So that would be definitely divergent. And what is the next jump in the pattern, do you think? But what goes here, though? Plus 20. Okay. So put a plus 20, minus 9 equals a grand total of what? Okay, that is the next term. All right, well, it goes here.